Hi, welcome to Orozco's Lectures. I am Jose Orozco, and these are my lectures. This lecture is a pre-calculus lecture. I hope you enjoy it. This is chapter 1.6, which is a library of parent functions. Alright, so these are functions you should, some of these you should already know, the other ones you need to be able to recognize. Alright, so first, let's talk about linear functions. Alright, and those are in the form y equals mx plus b. Alright, that's how you normally see them. We're going to call them f of x equals mx plus b, just so that we have it in terms of a function. Alright, now the way that these look are essentially, there's three different ways that a linear function can look. Alright, you can have a line that looks something like this, or like that, or like that. Alright, and these are the only ways that you can have a function, a line be a function. You know, technically for a line, you can have a vertical line, right, where the slope is undefined, but that would not be a function. So now, in this first scenario, this is where m is positive. M, recall, is the slope of the line. So the slope here is positive. In the second scenario, the slope is negative, and over here in this last scenario, the slope is equal to 0. All right, and in here, when we're talking about b, we're saying that b is the y-intercept. All right, and recall that the y-intercept is when x is equal to 0. All right, so we would say that this gives us the point 0b. All right, now let's do an example of one of these. Let's say that I say write the linear function for which f of negative 2 is equal to 6 and f of 4 is equal to negative 9, right? So I say write the linear function for which that is true. All I'm saying there is find the line where this happens, all right? And let's see what information we've got here. We're told that f of negative 2 is equal to 6. This is the same thing as saying this coordinate exists on the function, the coordinate negative 2, 6. Similarly over here, this is the same thing as saying that this coordinate for negative 9 exists on that. And why would that be? Remember, the inside is an x value, the output is a y value. All right, so that's why that this implies those coordinates. Now, what do we do here? Well, to have a linear function, we need two things, the slope and the y-intercept. So let's first find what the slope is. And the slope, the equation is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, right? That is the formula for slope. When I apply it to this point, I'm going to say, well, and in here, it doesn't matter which one I start with as long as I'm consistent. All right, so in other words, if I call this x sub 1 y sub 1, then I got to call this x sub 2 and this one with it y sub 2. Similarly, I can call this first point x sub 2 comma y sub 2, and the second point x sub 1 comma y sub 1. But as long as I'm consistent, I'm keeping the 1's together and the 2's together. All right, so it doesn't matter which of these two you decide to go with. Now, I personally usually choose the second one. So what we have here is negative 9 minus 6, right? Negative 9 minus 6 over 4 minus negative 2. And then what does that give us? Negative 9 minus 6 is negative 15. 4 minus negative, that really means plus. So 4 plus 2 is 6. And we can reduce these, right? They're both divisible by 3. Negative 15 divided by 3 is negative 5. 6 divided by 3 is 2. So our slope here, what we just found, is that our slope is negative 5 halves. Now, we want to have the linear function, right? So we want the y equals mx plus b. Well, what we're going to use now, we're going to use the point slope formula. And the point slope formula, let me remind you of what it is y minus y sub 1 is equal to m times x minus x sub 1. All right. And why am I using this? Because, well, in here, we require a slope. We found the slope. And we also require a point. We've got 2 points to work with, right? Either one of these is eligible to be worked with, all right? Now, so let's see. In this case, what are we going to do? So we're going to say that this equation becomes y minus, let's choose our y. And again, it doesn't matter which one. I'm just going to go ahead and choose 6. The slope, negative 5/2 times x minus. Now, because I chose 6, I have to take that negative 2. All right? You have to be consistent, keep them together. Now, from here, let's see what we get. Negative 5/2 times x is negative 5/2 x. This right here is technically a plus 2, right? So if I have negative 5/2 times a positive 2, that's going to be negative 5. And then if I move the 6 to the other side, I end up plus 6. So I end up with that y equals negative 5/2 x minus 5 plus 6, which simplifies to negative 5/2 x plus 1. All right. And in here, this is not really our final answer because I asked for a function. So we would say that our final answer is f of x is equal to negative 5/2 x plus 1. So that is our final answer now. All right. Now, let's say we wanted to graph this. All right. How will we do that? Well, in here we already got the slope and the y-intercept. So let's look for the x-intercept. So let's see. The x-intercept, recall that that's when y is equal to 0. Well, I'm going to say that negative 5/2 x plus 1 be equal to 0. I don't want to work with this fraction, so I'm going to multiply everything by 2. So I get negative 5x plus 2 equals 0. Solving for x, I end up with 2/5, right? Subtract 2 from both sides, I end up with negative 2. Divide by a negative 5, so let's go ahead and get the 2/5. And negative divided by a negative is positive. So this tells us now that we end up with a coordinate 2/5 comma 0. So now we've got a whole bunch of information, right? Because we already know what the y-intercept is. It's our b value, so that's y is equal to 1. So we have the point 0, 1. All right, so at this point, we can go ahead and sketch this. And it's going to look something like this. It's a negative slope with a positive y-intercept and a positive x-intercept. So it looks like that. All right, and here we've got the coordinate, this one right here being 0, 1. And this one right here being 2/5 comma 0. All right. So that's linear equations overall. Now, let's talk about quadratic equations or quadratic functions. So, quadratic functions. They are of the form f of x is equal to x squared. All right. And in here, this simple one as it is would just be essentially a parabola centered at 0. All right. But that's a very simple quadratic function. All right. So let's see in general what they look like. Well, they are a times x minus h squared plus k. All right. That's the form of that, where the axis of symmetry is the line x equals h. The vertex is at the point h comma k. And in here, if a is greater than 0, then we have a parabola facing upwards. And if a is less than 0, then we have parabola facing downwards. All right. So let's see what we get here. All right. In here, well, visually speaking, let's say it can look something like this, right? For example, if a were less than 0, if a is negative, it could look something like this, right? Where we've got our axis of symmetry being the point, the line x equals h, and this is the point h comma k, right? So that's essentially quadratic functions. So let's do an example. So let's say that as the sketch, right? Let's sketch a quadratic function. So example B, we've got f of x is equal to the negative of 4x squared minus 24x minus 31. All right. And I mean, that's a quadratic function. Now the question is, why do these look different? They're not in the same exact format. All right. So what we need to do is put it into that format so that we can sketch this easily. All right. So we're going to say here, well, to do that, we have to complete the square. All right. Complete the square. And how do we do that? Let's go ahead and try this out. So we have negative 4 times x squared minus 24x minus 31, right? And so that we can put it into that vertex format. Now, the very first thing I want to do when I complete the square is I want to have my leading coefficient be 1. Right now it's negative 4, so we're going to factor out a negative 4. And I'm only going to factor it out of these first two, all right? So we have there is x squared plus 6x, and then minus 31. Now, at this point, we're going to say, well, in here, we want to manipulate this so that we can have it into that format. So what I'm going to do is, I'm going to take this 6, all right? I'm going to use a dummy variable for that. So for example, beta, all right? Let beta be equal to 6. Then I'm going to divide that by 2. Beta over 2 is 3. And then I'm going to take that quantity and square it, giving me 9. All right. Now I'm going to use this 9 to manipulate this. And how are we going to manipulate it? Well, there's two things we can always do to any math problem. All right. Those are multiply by 1, and the other thing is add 0. So what we're going to do is we're going to add 0 here. All right. So what do I mean by that? Well, let's see. We have, so equals negative 4 times x squared plus 6x, and here's where I add 0. I'm going to say plus 9 minus 9, all right? Plus 9 minus 9. Notice that right there is just the same thing as saying 0, all right? 9 minus 9. Maybe I'll do it this way. And we still have this minus 31 on the outside, all right? So now in there, we want to continue to manipulate this. We want to factor this inside somehow, but we don't want this negative 9 that's in there. So what we need to do is take this negative 9 and take it out of the parentheses. Why? Because when we do that, this first part in here will be factorable, all right? The x squared plus 6x plus 9, it will be factorable into a perfect square. That's why it's called completing the square. So in here, what are we going to do? Well, to take that negative 9 out, we're going to take that negative 4 in the front and distribute it to it, all right? I'm going to multiply to that so that then I can take it out. So what do we get? We end up with negative 4 times x squared plus 6x plus 9. Negative 4 times negative 9 is positive 36, and then we have that minus 31. Now at this point, this is factorable, all right? Let's say even if you can't figure out right away how to factor this, these three will always factor into something square. What that something is your variable, x, and your beta. The beta over 2, excuse me. All right, so it's a positive 3, so plus 3. And then over here, 36 minus 31 is 5. So what do we have here? Let's see. Because we're trying to sketch this, remember. So what we have here is that the axis of symmetry is the line x is equal to negative 3. Now, why am I doing negative 3 if it's a plus 3 here? Well, let's go back to the formula up here, right? I said that I needed to have my axis of symmetry be x equals h, but that's when the format is x minus h. What I have here is an x plus 3. So essentially, what I'm thinking of that as is the statement x minus negative 3, right? And at that point, this is my h, all right? That's why my axis of symmetry is x equals negative 3. My vertex is the point, well, the h value, which was negative 3, and then k, which in this case is a positive 5, all right? And it is a positive 5 because over here, in the format, it was plus k, right? And we already have plus, so I just take the k value, which is 5. So that's our vertex. Now, what's our a? Our a is negative 4, which is less than 0. So we're going to have a parabola facing downwards, all right? So we've got a whole bunch of information here. The last thing that we need are some intercepts, okay? So let's figure them out. So we have the x-intercept, where y is equal to 0, and the y-intercept where x is equal to 0. Now the y-intercept, I like to use this version of our function. All right, remember this is where we found that that's our function. So in here, I'm going to say take -4 times x plus 3 squared plus 5 and set that equal to 0. All right. Solving, we end up with, well, x plus 3 squared is equal to 5 quarters, right? Subtract 5, but then divide by negative. So we end up with -5 over -4, which is just positive 5 quarters. And to take the square root of both sides, I end up with x plus 3 is equal to plus or minus radical 5 halves, right? I'm taking the square root of this, but because I'm solving an equation, I need to do plus or minus. So finally end up with x is equal to -3 plus or minus radical 5 halves. So what this gives me is 2 points. -3 minus radical 5 halves, comma 0, and -3 plus radical 5 halves, comma 0, right? Those are my two x-intercepts. Now for the y-intercept, all right, for the y-intercept is when x equals 0. For that, I like to go off with the original statement because it's just less calculation. So we have f of 0, which was -4 times 0 squared minus 24 times 0 plus 31. Not plus 31, minus 31, right? And at that point, this is simple. It's just -31, right? These zeros just go away. So we have f of 0 is equal to -31, so we have the point 0, comma, -31. And now we've got a whole bunch of information, all right? We have the intercepts, we have the axis of symmetry, the vertex, and which way it's going to open up. So let's see what that looks like. All right, so we have our axis of symmetry being x equals -3, right? So here we go. So here's our axis of symmetry. X equals -3, axis of symmetry. All right, then we had our vertex at the point -3, 5. So let's say that's around here somewhere. This is not drawn to scale. So this was -3, this is going to be 5. So this is the point -3, 5. And at that point, well, what is the last thing that we had here? We had some intercepts, right? So we have the point 0, -31. 0, -31, again, not drawn to scale. Let's say that that's there, -31. And we have 2 points here. Well, now, if you think about this, this is a parabola facing downwards, so it has to hit like this and like this, right? We've got these 2 points. Now, which one's which? In here, sorry, not there. In here, it's very easy to choose which one is which because the one that's minus would be to the left. The one that's plus would be to the right of our axis of symmetry. All right, so in here, this one is -3, comma, -3 minus radical 5 halves, and this one is -3 plus radical 5 halves. All right, those are those points there. And again, in red there, we've got the vertex. All right. All right. So let's do another one like this. So that's an example of how to graph a quadratic function. Let's do another one. So example C. Let's say that we have f of x is equal to 2x squared minus 5x plus 11. All right. And again, we want to complete the square here. So how do we do that? We are going to factor out the 2 out of the first 2. So we have x squared minus 5 halves x, and then that plus 11. And now to complete the square here, I'm going to take this value right here and use it into our dummy variable beta. So let's let beta be -5 halves. Then beta over 2 would be -5 quarters, right? Because we're dividing by 2. Remember, dividing by 2. So essentially here what we're saying, it's, perhaps we'll rewrite this. Let's rewrite this. We had -5 halves divided by 2. When we're dividing, that's the same thing as multiplying by the reciprocal. So I'm multiplying by the reciprocal of 2, which is, in this case, it gives us -5/4. That's our beta over 2, but we don't really care about that just yet. We care about beta over 2 squared. So what's that going to do for us? So that's -5/4 squared is 25/16. And it's a positive, right? Because we have a negative being squared. So at this point, what are we going to do with this? We're going to add 0. All right. So we have 2 times x squared minus 5/2 x. And here's where we add 0. Plus 25/16 minus 25/16. All right. And we still have plus 11 on the outside. Notice there that in yellow, that's just adding 0. So at that point, we're going to say, well, what we really want to do is group these first 3. But to do that, we need to make sure that we distribute this 2 to that -25/16 so that I can take that outside of the parentheses. All right. So that gives us now 2 times x squared minus 5/2 x plus 25/16, and then minus, right, because 2 times that is going to be -25/8, the 2 and the 16 reduced to 8, plus 11. At that point, we're going to say, well, these 3 always factor into the same thing, something squared. And what that something is our variable x and our beta over 2. So in this case, a -5/4. And then on the outside here, well, let's see. 11 in terms of 8 is the same thing as saying 88/8. All right. So at that point, we're going to say -25/8 plus 88/8 is a positive 63/8. All right. So that is what our function looks like in that vertex form. So now, in here, what does this tell us now? What that tells us is that our axis of symmetry is the line x is equal to 5/4. Notice I'm just taking the 5/4 because now we do have it as minus. All right. Our vertex is the point 5/4 comma 63/8. And since our a is 2, well, that's greater than 0, so we're going to have a parabola facing upwards. All right. What else do we need? We need intercepts. So let's get our x-intercept, which remember is when y is equal to 0. And I'm going to do that from this. So we have 2 times x minus 5/4 squared plus 63/8. Set that equal to 0. Right, and then, well, solving here, I end up with x minus 5/4 squared is equal to -63/16, right? Move this to the other side, it's negative, and then if I divide both sides by 2, it's the same thing as multiplying by 1/2, and that's how I get that over 16. But notice something here. I've got something that's squared being equal to a negative value. That's impossible within the real numbers, right? Within the real numbers, whether you're working with a positive number, when you square it, it's positive. Or if you're working with a negative number, when you square it, it's positive. So in here, this has no real solution. What we're saying there is that the solution would be a complex solution, and that is now within the Cartesian plane, all right? So we can't use that. So in here, no real solution, which tells us no x-intercepts. All right. Now let's look at the y-intercept. The y-intercept, which is when x is equal to 0. All right. And in here, well, we're looking for f of 0. That's simple. Just go back to the original statement. F of 0. This goes away. This goes away. We get 11. So f of 0 is 11. So we have the point 0, 11. So we do have a y-intercept, all right? And now, at this point, let's see what do we get when we sketch this? Well, we have our axis of symmetry at positive 5/4. Let's say that is our x is equal to 5/4, which is our axis of symmetry. All right. And then we've got our vertex at 5/4, 63/8. 63/8, let's say that's up here. That's our point at 63/8. And then we've got a parabola facing upwards. You know what? Let's shift this down a little bit, just so that I can make space. There we go. So that I can draw this better. There we go. Now, in here, we have our parabola opening it upwards, right? And we have our y-intercept. So it's in a parabola that opens upwards, so it's going to look something like this. Let's change that color. Something like that, all right? A parabola that opens upwards. Now this point right here is our y-intercept, which is the point 0, 11. So that's at the height of 11, all right? And there we go. Now we graphed that. And I guess I'll label this point our vertex, which was 5/4, 63/8. All right. And yeah, so that's two examples of quadratic functions that open up different ways. Now, what other functions should you be able to recognize? So the following functions you should be able to recognize even if you don't necessarily know how to graph them yet. All right. This all got messed up. Let's rewrite that. X is equal to 5/4. That's our axis symmetry. Okay. Anyway, back to what I was saying. Other functions that you should recognize. So let's label that as other functions. So you should be able to recognize the graph of f of x is equal to x cubed. All right. X cubed looks something like this. Right? And in here, the domain is all real numbers. That's the symbol for the real numbers. And the range is also all real numbers. All right? And again, the symbol is kind of like an R with an extra line. All right? That's the real numbers. What else? You should recognize f of x is equal to square root of x. All right? So the square root function. And that looks like this. All right. In here, the domain is from 0 to infinity. All right. And the range is also from 0 to infinity. All right. So it's the positive real numbers. What else? You should be able to recognize f of x is equal to 1/x. All right. And what does 1/x look like? It looks like this. All right, something like that. Where we've got a horizontal asymptote of 0 and a vertical asymptote also of 0. In here, the domain is x cannot be equal to 0. And the range is also, well, y cannot be equal to 0. All right, so those are both asymptotes in that case. We'll talk more about asymptotes later on. What else? You should recognize f of x is equal to 1/x squared. All right, 1/x squared looks something like this. Like a volcano kind of thing. All right. And in here, the domain is x cannot be equal to 0, and the range is from 0 to infinity. All right, and let me fix that. From 0, not including 0 to infinity, because you'll never touch the x-axis, so you can't include 0. The next one would be f of x is equal to the cube root of x. All right, the cube root of x. And this looks something like this. All right. In here, the domain is all real numbers, and the range is also all real numbers. But that's what the cube root of x looks like. Now, the last one that I'll talk about here is called the greatest integer function. All right. So the greatest integer function. And this is essentially what it looks like. Well, it's f of x is equal to this symbol. All right. The greatest integer function. You may have seen it with this symbol instead. All right. They both mean the same thing. Now, the greatest integer function is also called the floor function. All right. Essentially, what it does is it rounds down. Whatever input you put into it, the output is going to be the rounded down version. All right. So, for example, if I have f of 3.1, so what I want is the greatest integer that is less than or equal to my input. So the greatest integer that is less than or equal to 3.1 is 3. Similarly, if I had something like f of 4.9, I want the greatest integer less than or equal to 4.9. It's 4. All right, we're rounding down, straight down. What if I had something like a negative value, f of negative 3.1? All right, so I want the greatest integer less than or equal to negative 3.1. That's negative 4. All right, we're rounding down. Think about the number line. Here's 0. Here's negative 3.1. Here's negative 4. The greatest integer that's less than negative 3.1 is to the left, so negative 4. All right. So that's how that works with positive and negative values. Now, what does this actually look like? It looks something like this. All right. All the values between 0 and 1 get rounded down to 1. All the values between 1 and 2 get rounded down to 1. Similarly, between 2 and 3, including 2, but not 3, they get rounded down. Between 3 and 4, so on and so forth. All right. Similar idea. This is a kind of step function. All right. You may have heard it being called that. It's one of the possible step functions. And that is the end of 1.6.
Wasn't that fun? If you think I made a mistake somewhere, you're probably right. Tell me all about it in the comments. If you feel you learned something from me in this video, hit the like button, hit the subscribe button, but more importantly, share it. Share this video with your classmates. And remember, you don't have to like math in order to be good at it. But you do have to be good at it. I am Jose Orozco. Goodbye.